So today I have two different problems. Let's go start with the first one. Find theta if the inverse theta of square root of 2 over 2 is equal to theta. Okay, so assuming that we don't use a calculator in these problems, I'm going to assume that square root of 2 over 2 is going to be one of our popular angles in the unit circle for sine. So the popular angles are 30 degrees, 45 degrees, 60 degrees, then like 90, 0, 15 if we're using half angle formula. So I'm just thinking if this radius over here is 1, I need to find this y value over here. And so you can check through all of these values right here, which I will do right now. I'll just go in order: 30, 45, and 60. So if I say it's 30, that means that this length right over here has to be square root of 2 over 2. And so here's a little trick over here. Since this is 30, this is a right angle, this is 60, and that this is also 60. And so when we draw two triangles, one underneath the other, we have a 60, 60, and 60, meaning this is an equilateral triangle. And like over here, this has a radius of 1, so all of these are 1, which means that this right here is 1/2, which is not square root of 2 over 2. So we know it's not going to be 30 degrees. Now let's go and try 45 degrees. So if it's 45 degrees, that means that this is also 45 degrees, so they're going to be equal. And since the angles are equal, that means that the corresponding sides are going to be equal. So these are just going to be the same x value. And now we can solve using Pythagorean theorem. We can say 1 is equal to 2x squared. Since it's 1 squared is equal to x squared plus x squared, that means x squared is going to be 1/2. So x would actually be square root of 2 over 2, which is what we have. So we do know the answer is 45 degrees. I'm just going to go check, make sure it's not 60 degrees. And as you'll notice, the 60 degrees for sine is going to be what 30 degrees for cosine is. So if we draw our 60-degree triangle right over here, 30 degrees over here, and we draw another 30 degrees out here, so now we have our equilateral triangle. All lengths 1, this length, as you already figured out, is 1/2. Now we have this triangle over here, 1, a 1/2, and some y value. So I'll just use Pythagorean theorem. It's going to be 1 is equal to, here, I'll just write it over here. 1 is going to be equal to 1/2 squared, which is 1/4, plus x squared. That means x squared is going to be equal to 3/4. So x is going to be square root of 3 over 2, which is not what we have over here. So the answer is 45 degrees. Now we're going to go over to the second problem. So if the inverse of cosine of 1/2 is equal to theta, we need to find what theta is. Well, we already saw a 1/2 on the 30 and 60 degree triangles, so we just need to find out whether it's the 30 degrees where cosine is going to be equal to 1/2 or 60 degrees when cosine is equal to 1/2. So remember in the 30, 60, 90, we have lengths 1, then we have 1/2, and we also have, what was it? Square root of 3 over 2. Now, this is the biggest, this is the second biggest, and this is the smallest. Okay, so if we draw our triangle on the unit circle, we're going to have the biggest one over here, and then the second biggest, that's either going to be square root of 3 over 2 up here, and then 1/2 over here. And if this length is bigger than this length, that means that this angle is going to be the bigger angle compared to this angle, so it's going to be the 60 degrees one. And then if we draw a unit circle, and this right here is the bigger side, and then this one's 1/2, that means that this is going to be the smaller angle, and this is going to be the bigger angle. So if we need to find it to be 1/2, and of course cosine is the x value, we're going to have 60 degrees because the x over here is 1/2. So it means that cosine over here would be 60 degrees. Anyways, thank you very much for watching, and goodbye.